Hello friends, how are you? Today my topic is Deep Learning Lab 9 Neural Networks from Scratch and TensorFlow 101. Okay, so my outlines are you can see that neural networks from scratch, why TensorFlow, environment setup, TensorFlow to quick start, dataset preparations, building model via sequential API, functional API, and model subclassing, better performance with TF function, customized gradient flow by TF custom gradient. So moving to my topic, in this lab you will learn the fundamentals of how you can build neural networks without the help of the deep learning frameworks and instead by using NumPy. Neural networks from scratch. Creating complex neural networks with different architectures with deep learning frameworks should be a standard practice for any machine learning engineer and data scientist. But a genuine understanding of how a neural network works is equally as valuable. We are going to build a deep neural network with a three layer in total: one input layer, one hidden layer, and one output layer. All layers will be fully connected. In this tutorial, we will use MNIST dataset. MNIST contains 70,000 images of handwritten digits, 60,000 for training, and 10,000 for testing. Age 28 by 28 is equal to 784 pixels in grayscale with pixel values from 0 to 255. To able to classify digits, we must end up with the probabilities of an image belonging to a certain classes. Input layer flatten images into one array with 28 by 28 is equal to 784 elements. This means our input layer will have 784 nodes. Hidden layer reduce the number of nodes from 784 in the input layer or to 64 nodes. So there's 64 nodes in the hidden layer. Output layer reduce 64 nodes to a total of 10 nodes, and we can evaluate against them the label is in form of an array with the 10 elements where one of the element is 1 while the rest is 0. While instantiating the deep neural network class, we pass in an array of sizes that define the number of activations for each layer. This initialize the class by init function. Okay, as you can see, initialization the too smart. You can see that smart or initialization, we shrink the variance of the weights and biases in each layer. In cases you can see that we want to adjust the variance or to 1 by, and we divide the we divided by 1 by under root n. The initialization of weights in the neural networks is kind of hard to think about, which is beyond the scope of this class. In short, if we did not shrink the variance of the weights, the output y of the will become larger as the number of neurons grow, where y is equal to omega w x plus b. Okay, so after that we initialize both weights and biases during the you can see that drawing by the standard normal distribution. To smarten up our initialization, we shrink the variance uh, of weights and biases in each layer. In the cases we want to adjust the variance to 1 by n, which means divided by 1 or under root n. Okay, so I think this is enough for today. Now meet you in the next video. Goodbye.